last operators here, right?
Oh, really?
Oh, that's great.
My name's Sheila, I'm Jeremiah O'Brien.
Oh, you guys are going to have a hell of a party. Sounds like. And I think somebody, one of the guys, yeah, one of the guys said he's coming. Oh, okay.
1914, the American Marconi Company established this transmitter site with the transmitter building that we can't see right at the moment, but it's all the way out in that direction, right on the coast. And that was for Trans-Pacific communications, so initially to Hawaii and then to Asia.
And that had Anderson transmitters.
It
right?
did, but it started with rotary spark.
I see.
That was the standard in 1914. That was the standard Marconi high-power transmitter. So we see it rated at various times, and who knows how they calculated it, but at 230, 250 kilowatts.
Okay.
And motor-driven, obviously, motor driving an alternator, and then the rotary gap in an alleged soundproof room, but all of the gap itself was sealed in an alloy housing. But all the contemporary magazines all say, yeah, great, but you could hear it a mile away, so please, give me a break here. So that was in that building.
Is there anything left to see there?
There's the exterior of the building. The inside, sadly, there's really nothing to see. I should say very little to see. If you know what you're looking for, you can see the artifacts. We cannot go in it because it is truly unsafe at the moment. Not only because, you trip hazards and all of that, but because over the years black mold has taken over. But we just heard 2 weeks ago that the park is going to put some considerable amount of money into that to rehab the outside, get rid of all the junk that's in the inside. And once we can see the floor again, then we might be able to do things like outline where the alternators were and things like that. So, and maybe allow folks in, special tours like really good American Marconi Company, and you're out. Get out. And you're going to sell all your assets to the Radio Corporation of America, which they were forced to do. So RCA took over, said we're done with this spark gap, and that's when the two alternators went in. So each one of those, since they're a little more recent in time, we have a lot more information about them. So each one, 200,000 watts on 26 kilocycles, 26 kc, which was a high frequency for an alternator. As you may know, the existing one, SAQ in Sweden, they're on 17.2 kc. So the antenna here was a little short, even though it went all the way from the coast out to the road that you came in on. That, for that frequency, was moderately short for the antenna, but it worked great, and they lasted during the Second World War when it was shipped to Hawaii, and we think it was in 1957 that so that's when this building, the one with the green window sashes, that was built and went into service in 1930 to accommodate the new shortwave transmitters for the point-to-point service. It's still, no ship to shore yet.
Okay.
And then in the 1959, I think, then this cinder block building, built on the western edge of the original building number 2 to accommodate yet more transmitters. So the ship-to-shore service, KPH, did not arrive here until 1920, when the receive site was at Marshall. Did have a rotary gap transmitter ship-to-shore here, and then continuous wave transmitters, mainly in building number 1 out there. Shall we enter? Mm-hmm. This is a 1942. This is a 1942 vintage press wireless PW15 transmitter. And it started life as a point-to-point transmitter, and it was modified over the years you see these screens that are in the windows and the screens that are over the meters. All of that was done to try and get the transmitter to meet more modern specifications, because it was leaky as far as parasitics and harmonics and all the rest of it. So the work that they did to bring it up to FCC acceptable specifications in around 1979 was impressive. Also, they modified the output, which, as you see now, is an unbalanced coaxial output. There's originally a balanced output open wire line transmission system. So we kept that, but Steve reverse engineered these two cabinets. This is the low voltage, high voltage system here. To go back to using mercury vapor rectifiers, because we want to see that blue flash, we want to see those things. Of course, they had been modified to the, you've probably seen them in like vintage amateur gear. Guys will put in a solid state rectifier. So that was modified in that way here, which is exactly what you want when you have to keep this thing on the air 24 hours a day. This is a revenue generating thing. All this stuff, the whole purpose is not to have fun like we do in the ham radio circle. It's to make money, right? That's the whole thing. This is the medium frequency transmitter. This is on 500 and 426. It's the only dual frequency transmitter in the joint. And it's, of course, like all the rest of the transmitters, remotely controllable from the Point Reyes receive site. So this is getting warmed up, ready to go. And a lot of the other stuff that you see, and tons more, all came from the transmitter site in Palo Alto. We mentioned that the first iteration here was for point-to-point, not ship-to-shore. Fixed radio links across the Pacific. And that is a follow-on, a direct follow-on to Marconi's original business plan. That was the deal. It's going to interconnect the continents by radio, undercutting the undersea cables by 50%, undercharging by 50%. They went nuts. They sued him. He won, and he made a ton of money doing it. So this was the follow-on to that. And up at the receive site at Point Reyes is where all the shortwave receivers were for that. These were magnificent triple and dual diversity receivers, each one assigned to a specific city: Hong Kong, Singapore, Sydney, Guam, and I got to see that when I first got here, and you see the signs above each receiver. I just thought that was the most fantastic thing I'd ever seen. All of those receivers went to the dump, tragically.
What receivers were those?
They were radio RCA R3 dual diversity receivers. It's dual diversity, meaning that in this case you can have frequency diversity, so you've got the same signal on two frequencies, or in this case, space diversity, two different antennas feeding into the one receiver. Widely dispersed, high gain, narrow beam width antennas, let's say two stacked rhombics, each aimed at Hong Kong, but separated by almost a mile. So as you're getting fading on one antenna, you're getting a better signal on the other antenna. And in this module here, it automatically votes for the best one at any given time. But there's so much in this thing to achieve that I'm still trying to get my mind around it, only as far as operations go. Forget about how repair and restoration would go. There you go. My attractive assistant will pull off. There you go. Oh. Wow. This guy, as you see, is it's a transmitter. It started life as a spark transmitter, shipboard spark transmitter, using a type of spark gap called a quenched gap. And these were the highest evolution of spark transmitters. They were silent, which is amazing because all the other spark transmitters were just deafening. The quenched gap was originally in the panel where the rheostat and the 2 meters are. You notice how it's different from the panels above and below. The use of spark in commercial marine service became illegal at the end of 1939. So instead of scrapping this transmitter, they converted it to a tube transmitter. Now, I would much rather have it in its original form, of course, but still it's historically important because now it shows the transition between the two technologies. And to top everything off, literally and figuratively, they grafted this transmitter on the top. This is a single tube oscillator, high power single tube, self-excited, non-crystal controlled oscillator that's, according to the specs, good up to 12 megs. And we chose this one because it was in a little bit less horrible shape than some of the others. As you can see from the Dymo label, it originally was a transmitter going out to Guam, and then it was converted to Morse code service for ship-to-shore. This thing is, I can't open the door for you in the back because it's going into service today. The high voltage is on. We don't want to drop the thing offline, but when you take a look in the back, if you could, it looks like it came from the factory. And all that area of corrosion that you saw in the other transmitter, it just looks brand new. So the work that was done on this was just fabulous. It's the only place in the world, again, where you're not only going to see one of these transmitters, but see one in operation. It's on the kph 22 meg frequency.
Okay, because you've just stepped back into technology that goes back 100 years. So, and this is artifacts of that technology. I start by pointing out Senatore Guglielmo Marconi. The reason why is that he was the first person to say, I can make money sending messages without wires. So, A, it's cheaper than send messages across the Atlantic without that expensive cable. And B, if you're a ship moving around, it's really hard to have a wire trailing out of there. So those are very important things about Marconi.
Original last operators, yeah, right? Oh, that's great.
I made million shear on the Jeremiah O'Brien.
Oh, that's great.
I made million shear on the Jeremiah O'Brien.
Oh, you guys are going to have a hell of a party. Sounds like. And I think somebody, one of the guys, yeah, one of the guys said he's coming.
Yeah, one Reyes is down there.
Oh, okay.